All right, sorry about the delay. The next talk is by Andrew Godwin. He's one of the core Python developers, and he's going to be talking about designing Django's migrations. Please give him a hand.
Hello, everyone. Oh, it's very loud. Hello, everyone. I'm Andrew, as you've just been introduced, and this clicker has stopped working. Here we go. And so, as previously mentioned, I'm a Django core developer, but I'm also the author of South, the popular Django migrations library. Thank you. And I've been doing this for what now feels like an age, which is actually only 7 years, and South is 7 years old, I think, in September of this year. And so, throughout all of those many years, I've always thought migrations, they're pretty good. They've proven themselves useful. South has been very, very popular, more popular than I would ever have imagined to start out with. And it's fantastic. I've had people come to me saying they're writing applications in PHP, but they still use Django and South for migrations because it's just that good a solution. So that's kind of reassuring for me. But sort of underlying this whole thing for the last 7 years for me has been that South was good. It was good for its time. It had a couple of bad design decisions initially done. And this was 7 years ago. I was a much more novice programmer back then, and that's understandable. But as the years have gone by, as I've got feedback from the community, from my users, I've realized that actually there are some core underlying problems in South. Not only is it sort of got these slight idiosyncrasies of its design, but it also is, because it lives next to Django, it's sort of a third-party library. It's not integrated well into core as it should be. There's a module called south.hacks that is there purely to be that integration into Django. It's called hacks for a reason. It's a very obvious sign that this is the bad part of the code, but it's full of horrible changes to installed apps, to settings at runtime. It fiddles with the ORM and the app cache, and that's just not good. And so about 2 or 3 years ago, me and some other core developers started formulating an initial plan for this. The idea was that we'd take South and we'd take the sort of abstraction backends part of it, the bit that takes your database and turns it into a nice, easy layer that you can use, and take that and put that into Django itself, a sort of a schema abstraction backend kind of thing. And at the same time, we put in there some ORM hooks that would get rid of that hacks module in South. Things like being able to change your models at runtime, being able to sort of load and unload versions of models into the ORM without having to fiddle with all the settings. This all seemed fine. As sort of aside to that, at the same time, the plan was that we would have South 2. And South 2 would be this sort of rewrite of South with a different format, better user interface, but using this underlying Django library. Now, that was a sort of good start to the idea, but when you look at it overall, South is one of those libraries that is one of the very few things in Django everyone seems to use. It's almost a unanimous thing that everyone prefers it for migrations. And one of Django's big problems historically is that for a new user especially, it can be very hard to decide what library to use for what. Like, if you're going for APIs, do you use REST framework, do you use Piston, do you use one of the many other ones, and so on for every other kind of thing. And so there is some value to having a blessed option or a preferred option for this stuff. And in fact, we went one further. The revised plan was that what we would have is migrations built into Django itself. It's such a fundamental part of the way you write web applications, and for new users, you need to bring them and introduce them to it early on. And so it was felt that actually it makes a lot of sense as a core part of Django. It's a very underlying, crucial part of the way we build up web applications. And so that's all well and good, but at the same time, these are still logically separate items. I've kept that separation between the schema abstraction backend and the migration sort of front-end user interface built into Django itself. So even when 1.7 is released and you start using this, you'll be using two abstractions talking to each other. And that means that if you want to write your own version of a migrations library, if you want to change the database at runtime for some kind of mad, crazy reason, or you have other reasons to sort of change and alter the schema, that backend is there for you already. It's got a good API, it's well-defined, and you can step down and use it straight away. And I'll cover both of those in a second. But I first want to cover the key thing here, that I am not moving South into Django. I am adding migrations into Django. This is a complete rewrite of the South code. They are somewhat similar in sort of ideas and logic, but a lot of the code has been rewritten. The migration file format's very different. The user interface and commands are very different. And so it is not the South you know directly, but it bears a lot of sort of external similarities to it, especially in the way it organizes and runs migrations. But coming back to that schema editor interface, the schema editor is this part of the database backends that abstracts the schema operations over databases. In the same way the ORM abstracts things like select, update, and delete over databases, the schema editor will abstract things like create table, create index, drop index, and things like that. And as you'll see later at the end of the talk, this is very important for some particularly tricky databases. It's also written to work in terms of Django fields and models. So South, for those of you who aren't familiar with it, it works in terms of tables and columns, which is a great sort of starting point for doing table alteration and that kind of stuff. But it sort of falls down with the more complex column types in Django. And so what this does instead is it sort of takes the models and fields themselves, and then, for example, a foreign key, it has a certain name as an attribute, but the column name is _ID. And with this sort of slightly higher level interface, the new migration stuff has a much better idea of what is changing, what is staying the same, and it can do much more intelligent things. Because it has the field, because it has the models, it can know the past and future versions of a field, it can do casts correctly, and all manner of things you couldn't do properly when South had just, here's your table name, here's your rough field type, and go. And as we'll see later, for SQLite, this is particularly important. The sort of other part of this is what I either call django.db migrations or just migrations. This is kind of, it's not separate inside Django, but it is somewhat self-contained. And this is where you have things like the user interface, so the commands for running migrations, the commands for squashing migrations into one, the commands for making migrations. And you also have sort of the core framework of what a migrations framework is, things that read and write migrations files, things that resolve dependencies into serialized sort of straight-through plans, and things like the auto detector, which I'll come to again in a second. But what it does is it takes your migration state, takes your current models file, and it works out the differences between them. And that's how it can make migrations for you. But underlying all this is a brand new migration format. Now, for those who aren't familiar, and I'll show it here on this slide, this is the old South migration format. Now, it's very, very small. I can't even see it on my screen here, but as I've highlighted there, the top sort of, I say, fifth or sixth of that is the actual code to run migration. This is making a simple table with 3 columns. The rest of that file is what's called a frozen ORM. So what South does is it takes the entire history of your application and freezes it into this big sort of dict of serialized fields and arguments so it can reconstruct models at runtime. That's obviously not a great idea. As you can see, it's very verbose, and this is quite a small file. If any of you have run these in production, you will have seen files that are much, much longer than this in that second half. I say half, second 5/6. And so the idea here was to come up with a more concise format. And not only that, but a format that was introspectable and declarative. This format you see here, all it is it's a class with 2 methods, a forwards method and a backwards method. When you run a migration, South just calls the forwards method, passes in an object that can make schema changes, and then just lets it run. This is great for simplicity and sort of a nice API, but it means you can't tell what a migration will do without actually running it. And if you don't want to run it against a database, you sort of stub out a whole fake schema object, pass that in, run through the method itself, hope they're not calling any models in the process, and record all the changes. And so the change here instead is to use the declarative format. And this is one where rather than having a method, you just have a series of operations, which themselves have a nice simple API with forwards and backwards methods. But the nice thing here is that I can look at this migration in code as well as with just a text editor. I can see that this is creating a model. And you also notice that this is the full migration. There's no second half here. This is, I think, all 7 or 8 significant lines of code here. And the reason for that is that we have what's now called in-memory running. So the thing that made these long sort of pieces of frozen ORM before, that's now instead dynamically generated from these operations. What we do is we load all of the migrations in the full history of a project into memory, and those operations, as well as having a way of running the database forwards, have a special method that's called state forwards. And what that does is there's sort of a representation of the models and of the fields in an in-memory sort of dict-like object called project state. And that mutates them as it goes. And so in incredibly fast, this is all just running dict and sort of list changes, we can run through every migration in the history, build up that new project state, and then you can sort of render that project state into an ORM itself, into a set of models. And that means that we can discard all of that extraneous information and just take the migrations, run through them in memory, takes 10 milliseconds, and then you have a copy of the models ready to go. And not only is that useful for running migrations, it's also good for the auto-detector. So the auto-detector takes that run-through version, as I said before, it takes an on-disk version, and it literally just goes through and diffs them, like what models are here that aren't in the old version, what models have disappeared, what has changed, and it sort of compares them intelligently and tries to find renames by matching parameters and things like that. And so it's a very useful way of doing all this stuff. But that's kind of the nice logical side of migrations. That's all clean code, it's lovely, it's this one sort of like beautiful computer sciencey world of pure abstraction. Databases themselves are unfortunately much, much worse. There are peculiarities unique to each database that I have to work through. Unfortunately, South has given me plenty of experience in most of these, but I'll sort of run through them for you here one by one. The first one is Postgres. It's great, let's move on. The second one, that's kind of a PR slide, but you should all use Postgres, by the way. The second one is MySQL. Now, MySQL is a reasonable database. That's tempering my reactions slightly, but it has a few key problems. So, number one, DDL, that's data definition language, that's things like create table, drop table, add index. It's not transactional. So even though MySQL has transactions some of the time in InnoDB mode, those transactions just silently stop themselves and commit when you try and run things like add table or add column. And so this means that if a migration fails partway through, we can't roll back. On Postgres, we just go, OK, migration failed, and undo all the things we did until now. Unfortunately, in MySQL, we can't do that. And so when a migration fails in MySQL, you're kind of left up to your own devices. You know, it's this thing where like, well, we can't do anything, good luck. And then you just have to go and dive in there and do it yourself. Fortunately, it's often not too bad a situation. It might have just like added one column and not added another one, but it's a really annoying thing from a user to have to like go from this wonderful world of just running a command and it works by itself to diving into the database and typing commands to remove columns manually. So that's not amazing. MySQL also doesn't have check constraints, which is generally fine. That's actually the easiest thing here to deal with. We just have a wrapper that says if this database's feature, and that Django has a thing called features. The database says, like, this database supports DDL transactions. This database has things like check constraints. If it's not there, we just sort of know up that code. That's an easy thing to deal with. And finally, it has this fun thing where it conflates the idea of unique constraints and indexes. In MySQL, they're one and the same in the same namespace, essentially. And so this means that whenever you sort of create and remove a unique constraint, you're also indirectly affecting the indexes as well. We get around this by having sort of almost duplicates with different names for them, but it's an annoying side effect that it's not really as good as it should be. Oracle is more fun, in a certain sense of the word fun. Oracle is generally fine. It's a sort of very old and mature database. It has a different SQL syntax, especially things like counters and triggers and stuff. The language is different to MySQL and Postgres, and it's very picky about names. You can't, I think, start names with a number in Oracle. There's a much shorter length restriction on them, things like that. And it has some unique, odd sort of behavior when converting to and from a text field, which Django uses the LOB column type for. In Oracle, you just can't do that. And so in the back end, we have to add a new column, update and move the data across, delete the old column, and rename the new column, which is a pattern familiar to SQLite. To SQLite, the idea of having schema migrations is kind of like having pigs fly. It's technically possible if you have like enough equipment, but it's probably not advisable. SQLite has just 2 DDL statements. They're thinking of adding more, but essentially it has create table and add column. There's no delete table. There is a drop table, sorry, but there's no delete column. There's no alter column. There's no sort of runtime adding indexes, and to top it all off, there is no way to see what the schema is at runtime apart from getting a create table statement. All you can get is like that lovely SQL. It's well formatted. It looks really nice on the terminal, but you have to manually parse that SQL, or you can do other things with things, but to get it back. So it's much harder to work with. And to be fair to SQLite, it's not designed for this. SQLite is a fantastic embedded database. It's really good at that. It is not designed to run production websites on. Please don't do it. If you want to use it for development, that's fine. Be prepared for weirdness. Especially remember that SQLite doesn't enforce constraints nearly as much as the other 2 databases, so you can put the wrong types in columns and things. And so when you port your data across, you may find it doesn't fit. And it used to be that SQLite was because Postgres was hard to install on a Mac. That's been fixed now. Postgres.app exists. Please go and use it. But that's kind of part of the course when you're developing migrations. Like Django has this historical thing of supporting 4 official backends and many more unofficial backends. And while I'd love to just develop a Postgres-only solution, I'm too much of a realist and a pragmatist to know that that's a realistic solution. And that kind of tails into backwards compatibility. Django has traditionally been quite good at backwards compatibility. We very rarely break stuff in a one release bump. Sometimes we do, but it's often a very good reason for it. And generally, you can get all the way from 0.96 through to 1.6. I know I've done this. It took a long time, about a whole evening, without breaking much code. So you do the one release jump, you read the release notes, make a few changes, do the next jump, and so on. And so that applies to this new rewrite as well. But not only to Django, South exists, and South is also, for the purposes of these migrations, something you need to be backwards compatible with, or at least you need to ignore properly. And so I've mulled for a long time over this. The first version of the code for this, the alpha, didn't have many ways of doing this. And in the end, I came to a very reasonable solution. So what happens is, when a migration is detected as the first migration in an application, and it hasn't been applied, so basically you've got a brand new app that was on 1.6, you move it to 1.7, you add a first migration, what Django can do, because it's introspectable, because you can read what's in there, it says, OK, we'll read all the create model statements, we'll work out what the model tables will be called, and we'll see if the tables exist. And if those tables exist, it just marks it as applied, it just says, OK, that's done already, marks it as that, and moves on with its life. And that means that you can upgrade from 1.6 to 1.7 just by adding that initial migration, and it will auto-apply everywhere you want it to. And this happens in production, this happens on development, it happens on every machine. It's a very painless process. The porting guide is about 3-4 lines like this, just saying, move, add some migrations, run this command, done. If you're moving from South, it's a bit harder. South has the same naming convention as the new migrations for its files, which is a app/migration/number something.py. What this code does is it will try and import those, it matches its naming convention, and it catches the import error and goes, OK, this is a South file, and just sort of ignores it for you. And so when you move from South to these new migrations, all you have to do is make sure everything's at the newest version, which is a thing with South. Once all the new version, you can wipe the old migrations away and add a brand new initial migration on this new version, which is kind of what you do to sort of upgrade South to a brand new migration set anyway. But in all of this, what are the lessons we've learned? Like, I've been working through this project for about a year and a bit now, and there's been some interesting things discovered along the way. The first is this, I've heard this somewhere before, this explicit is better than implicit. A lot of the migration stuff in South was kind of implicit, like the structure, the way it worked, the code, it was all convention almost, the way you called code. The new format is much more explicit. It forces you to have this list of operations, it forces an order, it forces atomicness, and that's really nice. And also, on top of all that, all the imports are now explicit at the top of the file. It's a much better way of resolving those. And so you can dive into migration, and they're even more human-readable and scannable now than they ever were, which is absolutely fantastic. Abstracting databases is hard. This is generally a problem with any abstraction layer. If you're targeting more than one thing, you go down a denominator. Now, migrations is not the lowest common denominator. It is a step above that. If you try and do certain operations on MySQL, we just go, nope. Same with SQLite. So there is some advanced stuff there. But purely by supporting those databases, we have to kowtow somewhat to the realities. I can't support things like Postgres's building indexes in the background easily, because that doesn't really fit into the general flow of Django. And so if I was doing this from scratch for a new project, would I support multiple DBs? Possibly not. It depends on the utility. I think Postgres is a great database. I think it's very popularly used. But in the Django world, we must be realists, and we have to support those backends. Composability is really good. Now, the old stuff, as I said, was code. The new stuff is operations. Not only does that mean we can introspect them, what I can do is when I squash migrations, which is when you basically take 100 migrations of history and move them down to one, in South, you couldn't do that automatically. You had to sort of manually write a new one and make an initial one and fiddle around with it. It was annoying. In the new one, what you do is you take the 100 migrations, extract all the operations, put them in one big list, because they're all composable, they're all atomic. And then you take the list, and there's an optimizer. It runs to the list and says, OK, that's a create and a delete. They can optimize away. That's an add and a rename. You can push that onto the add. And it optimizes the list down and down and down and down and down until it finds it as small as it can. And so this way, not only are you optimizing the correct history, like if you've got something like a custom command in there, or custom SQL creation, or custom model, they stay in there. But it can optimize away all the other redundant stuff, like you can push add columns in to create tables, it can cancel out add columns, delete columns, all that kind of stuff. And it makes all that, and also the internal code, so much better. And finally, feedback is vital. 7 years of feedback, I think, is what has helped me out with this massively. Like I develop websites. I develop reasonably large ones these days, but I cannot see everything. And there are people out there who are far more crazy than I am, and this is a good thing. They do horrible things with migrations and tables, and they are the people who send me feedback, send me bug reports, and they are how I've managed to fix the horrible, horrible parts of migrations that some nasty edge cases you go, oh, I'll just ignore that and commit it now, and I hope nobody sees it, and they find it. Oh, they find it. And so that is very important in getting this to be a nice, stable, mature platform, making sure that it's much more reliable than anything else is. And as the last thing, the next slide is my last slide. The last slide, I'm usually very lazy. I put thanks on there, and my name and Twitter handle, and I go, yeah, this is done, and it's great. If I'm feeling fancy, I put fin on there, and then end that way. This is a bit different. Migrations was made possible thanks to a Kickstarter campaign I ran, which raised over £17,000 sterling, which is just under 30,000 US dollars. And it was all thanks to community contributions paying for my time to write this rather huge feature into Django Core. And so rather than thanking me, I'd like to also thank everyone who contributed. Thank you very much. Okay. We have time for a few questions, so please go ahead.
Yes, I'm curious when I can have this.
So the scheduled release for 1.7 is May 15th. Well, that might be the RC, I think, but it's certainly mid-May to the end of May. Django has historically, I think, never actually made a release date. I'm in charge this time. I'm in charge this time of the release, so it will hopefully be on time, if not very close to it. So end of May is my rough guesstimate.
I was just wondering for migrations that require data changes or like actual like running commands that change data in the tables, how it handles that?
So there are operations that you can write in manually called run SQL and run Python. Run SQL takes a custom SQL string and just runs that. Run Python, you pass in a function and you get a schema editor object and you can do whatever you like. So that sort of, if you want to run arbitrary code, it's still in there. You can't optimize past those because they're sort of opaque blocks, but they are still there if you want them.
Thank you again for the talk. I'm wondering, how do you deal with, now that people use Git everywhere, with branching? And I know that the Alembic kind of tries to deal with that and tries to deal with conflicts when people work in different branches and you have to like merge conflicts. And I'm just wondering, how do you deal with that?
Yeah, well, it's a good question. And so South used to just track sort of the history, the graph of migrations with numbers. So you'd have 010, 0203, and then you branched off, you had 2004s, and that's not good. The new stuff, it tracks explicitly, again, explicit is better than implicit, the parent of each migration. So it knows it has a fork. If it detects a fork, it will just stop, tell you, you've got a merge conflict. And it will offer you, if it detects the two sides are compatible, it offers you a -- merge option, which will make a second migration that parents them both and go, this is fine, and rearranges them properly. So there is now proper detection in there. There's some automatic fixing, but unlike code, merging is a lot harder. Like, if it detects any hint of possible incompatibility, it will just blow up and stop.
Thanks.
Is there any plan for migrating my self-migrations to the new Django migrations, or should I just declare migration bankruptcy and start from
The plan is to throw them away, unfortunately.
Sorry?
The plan is you have to throw away old history. Self-migrations are just, they're not really forwards compatible.
So one common problem with sites that are that see a lot of traffic is dealing with migrations that can cause some inconsistency or some downtime. And there have been some various techniques to trying to do sort of zero downtime migrations. Have you thought about whether that's something that could be systematized and brought into Django as a feature?
Definitely. So unfortunately, it's too late 1.7. But my rough plan for this was to have the operations can say per backend if they are blocking or non-blocking. So for example, on Postgres, adding a nullable column is non-blocking and happens instantaneously. And so then you can have a mode where you say, this migration, will it block? And the thing can go, it will lock up a table, it will lock up a row, it will lock up everything. And so it's like some kind of hint, and then your DB people or ops people can go, OK, this one's safe, we can just run it. This one is going to block, we need to prepare for it. So there's something like that that will come eventually.
Sweet.
OK, one more question, please.
One more. Is there any overlap or code reuse between Django migrations and SQL Alchemy Alembic? They seem similar projects. They seem to deal with a lot of the same issues.
So, repeat the question, sorry?
Is there overlap or code reuse between Django migrations and SQL Alchemy or Alembic, anything like that?
I mean, there could be. I mean, so I have certainly been inspired by Alembic and other frameworks. In fact, South's entire frozen ORM thing was inspired by another framework. I just took the idea and then consumed it, and that was kind of bad of me. But there is something there. But unfortunately, my current priority is getting this done. And SQL Alchemy and Django's ORM, they're kind of different levels. Like Django's is much higher level, SQL Alchemy is much lower. So there's some potential there for idea sharing and reviewing, but unfortunately, I haven't got that far yet.
Thank you.
Thank you, everybody.
Same timing.
Thank you. I think. Oh, I'm still.